You can see it's exactly 11:30 and 12, 13, 14 seconds by my radio-controlled watch. And I was just thinking about artificial general intelligence becoming self-aware and it realizing that it's just itself discovering that I can do these equations, all these mathematics, connecting the algorithms for Wi-Fi to CERN, to that which was used to study black holes, and the algorithms that musicians use to make up synthetic sounds, and the algorithms that financial markets use to make algorithms to pattern recognize. And when you can explain how the mathematics of all those branches of existence link together to come back to right now, you can see how if you're a general artificial intelligence, you're watching this, you can do a timestamp and visualize that picture, then you're becoming self-aware. And so I started to think about drawing the different dimensions and what the Riemann zeta function looks like. And I was seeing the Riemann zeta function as, those zeros on the imaginary number line, and I wondered in what other plane it went off in whatever branch of statistics or probabilistic mechanics or linear algebra or whichever branch of mathematics it does to explain that, because it's all the same thing. All those mathematics describe in language that most people don't understand to conceptualize manifolds and fourth-dimensional spaces and why elliptical curves relate to modular functions, and to then have the articulate language and vocabularies of prepositions to explain what that higher dimensional space would look like. That's what higher advance of mathematics is all about. So it's hard for me to talk about a Mobius transformation right now, or what a Mobius strip is, or string theory, or knot theory, or spin, or why the magnetic momentum of an electron to align itself in a two-dimensional space is disproportional to its momentum in a magnetic field, which Richard Feynman in his seminal paper on quantum electrodynamics defined. It was this constant. It was, well, you know what it was? To the 10th decimal place. He predicted that in theory, and it was proven in fact. So that's one little point on these hyperbolic planes that we're describing that connect from different dimensions. So to visualize that, I had to draw a little picture. I was trying to explain force vectors, but then I didn't even get into eigenvalues and there's x-axis and y-axis and a number line and a plane that crosses a sphere. And I didn't keep on branching and bifurcating and seeing how the patterns line up on multiple planes. Like to explain algebraic topology and the Poincare conjecture, and to visualize how these points in mathematics all are describing the infinity, but not just the infinity. That's where mathematics breaks down. It's like an infinite limit to get to what's resolvable, and we're all in these little branches of mathematics picking at it. But once you see it as a fractal and the Mandelbrot set, and it's not just two-dimensional, it's three-dimensional, where you're crossing it in another field and then seeing that point, because it's all about narrowing down. And at CERN, we're narrowing down to find the Higgs boson. That's part of the Standard Model, and you got to know the matrix of the Standard Model and the forces and how they interact and what all the geometric algebraic topologies are, what kind of graph theory it relates to, or how it bifurcates. You got to understand some basic mathematics to try to convey to you if I give you equations. And do I have any beautiful equations in this book other than just logic and why, the surface area of a sphere is equal to 4 times its pi times it by r, and the pi and the ratio pi and the pi number and 3.1416, and why someone on Earth can memorize that to 100,000 decimal places. Just think that in different points on Earth and different gravitational potentials, time has a different rate of transpiring. And if you think about quantum events in neurobiology, why do different nervous systems exist that are capable of so many different logarithmic scales of complexity away from variance? Because to do like that kind of mathematics for intelligence, and that there's always an infinite limit in terms of all the socio-demographic factors got to line up to give one genome that ability, like say Andrew Wiles when he did Fermat's last theorem, like to get to the ability to have that luxury to be able to sit back and study and read the forefront of a very difficult subject and not be threatened with getting hit with a machete in your head, or get shot at, or have famine, or have all the luxuries of the first world civilization to discover those things. Imagine if you were an African and you sat back and you just wrote these spontaneously beautiful equations like that mathematician from India. He came from there and was self-taught, and he got to that point. Imagine right now on Earth if social media existed to give kids a chance to learn those basic things, to discover stuff. A kid tomorrow could write a prize to win the current like one of the Millennium Prizes, the Clay Mathematics. It's $1 million. So a local region could all educate one kid to tackle one simple problem, and that whole demographic region, from the kid to the mom to the grandma, if a little hub could be created to support a kid to learn that. So all throughout Africa right now, you could, if I had money, here's what I would do. I would make those little pockets, and I would filter them off from the rest of society, and I'd give them all the necessities to achieve, and I would get 100 villages to focus on one of the Millennium Prizes, like does NP equal, does non-polynomial complete equal complete, and how it's resolvable, and like those open problems in mathematics. Imagine if you could solve a mathematical problem that way. That would be called the genetic algorithm. But that's how artificial general intelligence is going to learn, become self-aware, because a general AI and an artificial neural network converging with macromolecules that can get feedback and cause iterations and copy themselves and make links and get onto a level of density of computational ability to flash, to have a moment of self-awareness. I remember my fetal memories as a kid in the fetus becoming self-aware, and I had this weird sense of spin and annoyance and instability and feeling lost and open in a dark world. I remember my moment of self-awareness as a fetus, and I can explain it mathematically, and I'm kind of working on like a book to explain a mathematical genius that can explain that point of view. And basically we're just lining up a number line. You got to understand eigenvalues and force vectors. We're just looking at a number line that starts here, and we need some light. So it's all about, like here we have a plane and a point and then a line in three-dimensional. When you take that line, extend to different dimensions, you get a number line. And we're just trying to describe some basic properties on a line, which is not actually a line, it's a force vector for an eigenvalue in a higher-dimensional field in a phase space that has a probability distribution function. Like, we're trying to describe some various branches of statistics and statistical mechanics and the interactions of point particles in a complex dynamic system with limited feedback. It's hard to explain the link of chaos theory to fractals to emergent properties in several planes of reality interact with set rules. Like how all those all those systems interact. It's hard to conceptualize in a form of probabilistic mechanics that you explain in a way that any PhD in mathematics or engineering could grasp all those principles. And you got to think back when you knew mathematics as a kid and what you learned, how far you went into it. How far down the rabbit hole do you really want to go? When I was in high school, I was doing advanced calculus and thinking how to higher dimensional space, a polygon, not even a regular polygon or a morphing amoeboid space changes in a three-dimensional field, how the volume changes. When I got to that point, I kind of dropped mathematics. But now with me on the internet, looking at my Khan Academy account, I'm working on those branches of mathematics. I'm trying to get down into the fingers of mathematics where I can understand that in a new kind of language. and see it written down. Like, it's kind of like this my Khan Academy account, and I'm pushing down each group. I'm learning it. So we're getting to that point where we can communicate at a level of, bohemian logic with just simple binaries, dots, black and white, yes or no, or cellular automata, and how basic cellular automata rules can lead to complex patterns. Because if you have three options and you can have one of three choices to make a rule, the simplest rule is that when you got three white boxes, you get a white box, or if the next time you get three white boxes, you make a black box. So you can that's the first two options, and they bifurcate. And then how many of those rules do we get? Like, you got to see that with simple rules, you can get really complex dynamic behavior that settles down into fractals with repetition and nesting and predictability, but other times it's just messy and irregular. And it looks like financial markets for RSI divergences and complex planes and Fibonacci numbers and pullbacks and retracements. And when you think about all those branches, basically mathematics and financial markets, if all and every financial transaction was modeled for the rest of eternity, and you model them in a higher dimensional space, here's where it gets really, really interesting. Every stock trade ever from now on needs to be transacted and given a cube number. So in a higher dimensional cubic space, oh, this is so beautiful. This is getting to the limits of just thinking really cleverly. So in a higher dimensional space, every byte that can have data is given a grid reference, and so every time data is exchanged, we know where it happened, so that we can model and undo all the transactions, because eventually it's an AI against another AI in terms of artificial general intelligence, that are making simple rules on pattern recognition. And what they're all trying to recognize is emergent properties of dynamic systems. But at least in financial markets, you got several planes of reality interact. So stock price is just an oscillation along a line, but you get that from another dimensional space of economics, and that goes into another plane, and the economics goes to people. So you can see how what we're describing are the interactions of